everyone, welcome to our second Q&A session for BEAMP Cycle 4. Today's session will cover the challenge statements under the thematic pillar of Advanced Design and Fabrication. I'm your host for today's session, and today we are joined by our challenge statements owners as well as the representative of the BEAMP committee. To kick us off, we would like to invite Anna Leong, Executive Manager from Built Environment Technology Alliance team of BCA, to say a few words. Anna?
Yeah, thank you, Abel. Good afternoon to everyone. I'm Arnold from the Built Environment Technology Alliance, or BETA in short, an outfit at BCA. So a very warm welcome again to the second Q&A session of the Built Environment Accelerate to Market Program, or BEAMP in short, a platform to bring innovators and firms together to fast-track the innovation process to solve challenges in our sector. So after an exceptionally challenging few years with the COVID pandemic, we are finally seeing an evident recovery as well as strengthening of the sector and reopening globally. The built environment sector is therefore seeking to both regain lost ground and to break new ground. And this cannot be achieved without the technologies and innovative solutions that have now become imperative to our businesses. As the sector emerges stronger, we are also optimistic of the new opportunities for technologies and innovation. And this year, we are in our fourth cycle since the inaugural one in 2019, and we are glad to continue this partnership with Padang & Co., our appointed accelerator, as well as Enterprise Singapore and JTC. We are glad that you have taken some time this afternoon to join us today and be part of the BEAMP Cycle 4, which has continued to garner the interest from the industry with 13 challenge statements in areas such as digital asset delivery and project management, building inspection, maintenance and facility management, automation and robotics for construction, as well as advanced design and fabrication. To our challenge statement owners, it is encouraging to see new faces as well as some familiar ones whom we are grateful for their continuing support. And we warmly welcome you on this journey with us to build up our built environment innovation ecosystem, to co-innovate and create new partnerships. To the prospective innovators, this is a window of opportunity to establish networks with our firms, as well as potential investors to develop new expertise or to match your expertise with the industry firms. And in doing so, we hope that sustaining investment partnerships can be forged between our innovators and firms and lead to both our firms and innovators building up their innovation capabilities, as well as new competitive advantages to bring about greater growth and revenue. The theme of today's Q&A session will be in the area of advanced design and fabrication. And we will see each of the three firms, namely Soy Built, Greyform, and NetSteel, make a short presentation and provide more insights to their challenge statements to allow prospective innovators to appreciate the challenges at hand and also understand the requirements and hopefully inspire and generate new possibilities towards the desired solutions and outcomes. So please do feel free and do not hesitate to step forward and clarify. And last but not least, we hope you will find this session fruitful, enriching, and also inspire you to develop new and meaningful partnerships. So I wish you all a good start to BEAMP Cycle 4 as you embark on this exciting journey with us. Over and back to Abel to kickstart the session. Thank you.
Thanks a lot, Anna, for the warm welcome. I must highlight that Arno is an important champion for the BEAMP challenge, and you'll definitely hear a lot from him and receive his generous support if you're selected for the program. And introducing myself, I am Ibel, the Program and Partnership Manager here at Padang & Co. Padang & Co has been reappointed to be the acceleration partner of the fourth cycle of BEAMP, and we have exciting plans in store for our previous cohorts of innovators as well as for innovators that will be selected for Cycle 4. And this is the agenda for today's Q&A session. I will first give a brief introduction to BEAMP Cycle 4, answer some questions that you might have regarding the program, and then we'll proceed to hand over our time to our challenge statement owners with us today to share about the challenge statements that are listed on this slide. Representative from the BEAMP committee, We'll also be staying back for a while at the end of the session to address any further questions you might have. So why BEAMP? You might heard of the Built Environment Accelerate to Market program for BEAMP. In short, it's a great platform and opportunity for innovators like yourself to co-develop, test bed, and pilot solutions with our challenge statement owners. You'll work in close consultation with the challenge statements owners to refine your solutions based on their requirements and thus get your solution ready for adoption and commercialization. Furthermore, successful eligible innovators will enjoy co-funding support from Enterprise Singapore for prototype developments, test beds, and pilot development. Successful innovators will also enjoy pitch coaching and refinement specially tailored to your company's business and solution to prepare you for the industry showcase events that we will be organizing, such as the Built Environment Demo Day. BEAMP is also a great platform to access a wider network of partnership opportunities and expand your company's exposure to local and international network. I would like to take this opportunity to do a quick shout out to our ecosystem partners that have kindly agreed to support BEAMP. Thank you, partners. We are currently in our 4th cycle of the program, and we have worked with over 50 industry firms to identify 93 unique challenge statements. We have awarded a total of 35 projects over the past 3 cycles, and you'll learn more about some of our past projects by visiting stories page on our website, beamp.sg. My colleagues will be helping to drop the link in the chat. For Cycle 4, we are excited to have these leading firms of the built environment sector to come on board as our challenge statement owners. Some of them are long-time supporters and also beneficiaries of the program. On the other hand, we also have new firms that contribute a diversity of challenge statements and thus new innovation opportunities. So today, we'll be featuring challenge statements under the Advanced Design and Fabrication pillar. We'll also highly encourage you to register for other Q&A sessions if you're interested to learn about the challenge statements under those thematic pillars. The dates are currently displayed on the slide, and the timing will be the same as today's session. While the recording of the Q&A session will be made available on our website on a later date, we strongly recommend a live attendance of our Q&A sessions because our sessions present an opportunity for you to interact with our CSOs before submitting your proposals and helping them to form a stronger impression of your company. So the first Q&A session on digital assets delivery and project management has already been uploaded to our website. Please take a look if you're interested. And do sign up for our next Q&A segment on 4th October. Next slide, please. Okay, so this diagram explains the process of making an application up to the award of projects. We are at the first step, which is the Q&A session. We encourage innovators to maximize this opportunity to ask questions to our challenge statement owners so that you have all the information needs to prepare for your proposals. Proposals submitted by 14 October will be shared with our CSOs for preliminary reviews, and selected submissions will enjoy priority to schedule consultation with our CSOs. You could also benefit from the feedback provided by representatives of the BEAMP committee, which comprise of staff from BCA, JTC, and Enterprise Singapore, as well as the Padang & Co. Resubmissions of your proposals is allowed until 7 November 2022. 7 November would be the application deadline for innovators that did not make an early submissions. And depending on the relevance and overall strength of your proposal, only selected innovators will be prioritized for the consultation sessions, where sessions could happen at any time between the early submissions deadline and selection of the innovator by the challenge statement owner. Please note that there will be multiple sessions with the objective of ensuring clarity and alignment between the innovators and the CSOs, especially on the outcomes of the resulting project. The evaluation and shortlisting process will occur in the following manner. Your latest application of the BEAMP Cycle 4 will be reviewed by the BEAMP committee and our CSO. The BM committee will be checking your application details to ensure that you are eligible for the program and funding, and also conducting their own assessment of the proposal. The latest version of the proposal will also be channeled to the CSO, and the final rounds of consultations will be arranged once the CSO are confident of their selection, and they'll issue a letter of intent to their preferred innovators and their feedback on the innovators to the BM committee. Innovators will be shortlisted by the committee with the consideration of the feedback from the CSO and the outcomes described in the letter of intent. Shortlisted innovators will be invited to present their proposals to the BM committee and provide further clarification as necessary. The decision to award the ASD or MD projects will happen in January 2023 onwards. Awarded innovators will need to complete their grant application process in order to receive the requested funding support. Projects may commence once you receive notice from the BM committee regarding the award. And there are 2 development tracks for BM. You will need to apply for the appropriate track depending on the tech maturity of your proposed solutions to address the challenge statement. So please note that we also welcome innovators with well-developed solutions and can help to facilitate the direct tech matching of our CSOs. So we have 2 tracks. Just let me explain a little bit more to you so that you understand which track to apply for. So if your company has just discovered the challenge statement or is in the early stages of developing a solution that could potentially address any of our challenge statements, you should apply for the ASD or Accelerate Solution Development track. Or ASD for short. So the proposed scope of the development for the ASD track should be planned to be completed within 3 to 6 months. So examples of activities that could be carried out during the ASD period includes user studies or tests to ensure the usability of the solution, develop prototype or run simulation to demonstrate technical feasibility and accuracy, to align the solution blueprint and pilot implementation plan with stakeholders, or conduct cost-benefit analysis to ensure the viability of the solution. BM will also help to subsidize your development costs. Funding support for the ASD track is capped at 30,000 Singapore dollars or 70% of the qualifying costs. If your company has already developed a prototype or early product and you have identified that there are further developments needed to ready your solutions for adoption and commercialization, then you should apply for the MD or Market Development track. The proposed scope of the development of the MD track should be planned and completed within 12 months, and it should result in a complete solution that can be commercialized. For the MD track, you should seek to further develop your solution to sufficiently address the requirements of a group of demand drivers that can serve as your early adopters. Activities could include deployment and testing of your solutions in sites with real operating conditions, integration with existing systems, and practical developments to make your solutions enterprise ready. Funding support for the MD track is capped at 250,000 Singapore dollars or 70% of the qualifying cost. It is important to note that projects that successfully complete the ASD track are eligible to apply for the MD track to continue the solution development initiated during the ASD. So how do you apply for the BM Cycle 4? I hope that I have managed to pique your interest to apply for the BM Cycle 4 after you have learned more about the challenge statements in today's session. So these are the steps to apply for the program. You can visit our website, bm.sg, and click the Apply Now button at the top right-hand corner. You can download a proposal template and fill the proposal template up. It includes details like your proposal and your funding stage, things like that. And once you complete the application form, upload your proposal and the requested documents such as your Accra business profile, pitch deck, and CVs of the core development team. So I believe my sharing has helped you gain clarity regarding the BM process, but that might be some details that I might miss. So I'll pause here for a few minutes to address any questions you might have. Let me just take a look at our Q&A box to address any questions. So do remind that we have our chat as well as the Q&A. If you have any questions, do drop your questions in the Q&A segment. Okay, I'll just wait for a few minutes to let the questions flow in. And my colleagues will be answering some of your questions by typing out the answers, just to give more airtime to our challenge statements owner with us today. Well, I see some with the funding from Natalia and from Ivan. Yeah, sure, no problem. My colleagues will be dropping the answers to you right away. If you can have a few more questions before we move on. So you can find the Q&A button at the bottom of the screen. You can drop your questions there.
Just to quickly address one of the questions. So applying for either of the track does not disqualify you from the other. Though, I mean, it should be, the Accelerate Solution Development, it is the earliest track, which then after you completed your Accelerate Solution Development, you could be eligible for the market development track. So basically the track is meant to be progressive, starting with the ASD track. I hope that clarifies. Yeah, so Ivan, regarding your question, right? So as part of your proposal, you will need to provide information regarding your solution. And you will also be requested to describe the development that is required to be able to sufficiently address the challenge statement. Under each challenge statement, there are the requirements that is described by our challenge statement owners. So do review the challenge statements and see whether your solution can address those requirements in a comprehensive manner.
Yeah, so well, since we are addressing the questions, the next question is the likelihood of being funded the same time for both tracks? Definitely. I mean, if there are merits to the ASD stage proposal, and we have validated the scope of the project well, and it shows great potential, then definitely there's an opportunity to progress it into MD stage, because we will definitely want to see it being implemented and being commercialized. All right, so as we go along, you guys can just drop all your questions into the chat, into the Q&A session. My team will be addressing them to you at any time. Okay, so for the agenda for today, I would like to just bring your attention to these 4 challenge statements that we'll be covering today. The first, next slide. The first challenge statement is the digital test of concrete strength development in precast production. So Daryl from Soybuild will be presenting that, followed by we have Saran from NetSteel. He will be presenting on the challenge statement of mechanical splicing and of reinforcement bars. And the last two challenge statements will be covered by Sotian from Greyform. So the first challenge statement will be referencing and marking of fabrication for prefabricated bathroom units. And the last one will be automated inspection of precast components. So I'll now pass the time to Daryl. Daryl, please.
Yep. Hi, Ibel. Can you hear me?
Yes.
Let me just share my screen.
No problem. Thank you, Daryl.
All right. Can you see my screen?
Okay, perfect.
All right. Good afternoon, everyone. Thanks for the introduction, Ibel, and also to Arno for that lovely welcome. So yes, my name is Daryl. I'm the lead for innovation and sustainability at Soybuild Group. So today I'll be presenting one of our challenge statement, and that is actually on digital tests of concrete strength development in precast production. So why we decided to explore this challenge statement, really because the current method of concrete inspection is actually not sustainable in our point of view. So we want to develop something that is for the long run. And at the same time, to meet our larger objective of trying to reduce carbon emission. The direct objective from this challenge will be, first of all, to reduce wastage, and in particular, the wastage that's derived from your conventional cube concrete testing method, and also to enhance production efficiency, which I will explain a little bit on after this. So a little bit of a background of where I come from. This solution is meant for the prefabrication division of Solbuild Group, namely Precast Concrete Private Limited. And under Precast Concrete, we actually own what we call the ICPH, or in long integrated construction and prefabrication hub. Now, in this ICPH, the way we do our precast components is based on a just-in-time manufacturing principle, which means that our design is done on a BEAMP modeling tool, and with all the digital file being transmitted throughout the entire life process of the prefabrication process. There is one area which I circled over there, which is actually the concreting process of this prefabrication system. And as part of this concreting process, there's a need for us to actually measure the concrete strength development of our precast components. Now, how do we do it? Conventionally, you will use a cube mold as shown in the picture. And then after that, you will actually pour concrete into it. You let it cure, and probably after a good 12 hours, or depending on the number of days that you want to test it for, you'll have your casted cubes. You also at times place it inside a curing tank. And how do you then determine the concrete strength eventually is you put it through a compressive test machine. All said and done, basically this is the conventional way of us doing the concrete cube testing method to ascertain either your early age strength gain or your later age strength gain. But in doing so, it is actually very laborious. You will need labor to come in to set up the cube mold, to cure, to pour the concrete, to crush the concrete as well. And it is actually very time consuming. So these are the three main opportunity areas that we have identified. First of all, I think we are looking, in comparison to the conventional testing method, a real-time strength development monitoring system. Why do we need this? Because in a plant like the ICPH, and we produce our components in a just-in-time manner, if you can ascertain the early age strength accurately in real time, then you are able to accurately demold it earlier. All right, so it gives you greater accuracy in ascertaining the early age strength. The second opportunity area will be to minimize wastage of materials. I think based on our calculation, we could save about 3,600 cubes for one block of HDB alone. So just to paint a picture, if you do it on a plant basis, you will need to test for your concrete cube strength every 40 meter cube. All right. And in every 40 meter cube, the bare minimum is that you will have to test 2 cubes at the demolding strength timing, 2 more cubes at 3 days, 2 more cubes at 28 days, and as a buffer, you produce another 2 more cubes as spec. If you do it on a project basis, then you will expect many more cubes to be casted. The third area, we are looking for something that is that has low implementation cost. So we are looking at less than 1% of component raw cost. However, this is, I think, subjective, depending on a case-to-case basis. But why we put this in is because we want this solution to be sustainable, which means that in precast and prefabrication alone, if you were to implement a digital solution that is way too expensive, it may not be feasible in the long run. So something that is cheap to implement, however highly effective, that's what we're after. So what are the expected outcomes? I think first of all, very direct. We want to reduce the number of cubes that are being casted, crushed, and tested. At this point in time, I think to be realistic, we are not looking to entirely replace the current cube testing method. So we will run in parallel. which means that we do the conventional method while having a potential solution to actually mirror it. So both runs concurrently. So with that, we expect 50% reduction in cube testing. The second outcome will be a 25% increase in casting cycle. Why we believe this is achievable? Because with the current cube testing method, you tend to test it probably at 12 hours, but if it's past midnight, then you will wait another 6 more hours. There is a time lag over that. I think you can't expect your workers to be awake 24/7. However, with a real-time strength monitoring system, you are then able to measure the strength development at any instantaneous time. So the moment it hits the required demolding strength, you can straight away demold. So that's the rationale. And last but not least, I think we will hope to have an integrated dashboard system to allow stakeholders to view this real-time monitoring, and hopefully in the long run to be able to link this dashboard system to the relevant authorities. For example, if we were to produce components for HDB projects, then the HDB team will want to have access to this dashboard system so that you don't have to then rely on conventional method of sending emails, going through Excel sheet, which is time consuming and labor intensive. So with the integrated dashboard system, we hope to bridge that gap. So I kept my presentation short and simple. I'm open to any questions that you may have. And yes, thank you. And I think I'll pass back the time to you, Ebel.
Thank you, Daryl. We do have one question for you. So how does this solution to reduce cubes to be applicable with compliances to the government? Will this affect the marketability and feasibility of the innovator solution?
I'm just trying to read the question here. This is by, hold on a minute. Okay, how does this look? Okay, so I'll answer the first part of the question. I think in terms of the applicability with compliances, this one we will have to work hand in hand with the local authorities. Why I say that? Because the current method, I think or probably if you look at the current testing method, it is the conventional way of relying it on cube compressive machines. You crush the cubes and then you get the strength out of it, right? But nothing is stopping you to then explore other methods. Say, for example, maturity method, which has been implemented overseas. So to cut my answer short is that we will have to work with the authorities to prove to them, and I think that's the reason why we will want to do up the pilot test to test it out on our actual components and to do a benchmark comparison with our existing system, whether is it performing on par or whether is it performing better. If the solution proves to work better, then I think we will have an easier time to convince the authorities. And I think such a solution, I think it has been implemented overseas, but different contexts, different geographical locations will have different requirements. How our concrete cures under humidity of more than 80% in Singapore will make a difference as well. So all this comes into play. The second question will be on, wouldn't this affect the marketability and feasibility of the innovator solution? I think we have to draw this two apart between compliance and marketability or feasibility. We will have to draw these 2 points apart. Why do I say that? It's because we should not, because of existing regulatory compliances, and then we limit ourselves to potential solutions. Then it goes against the whole idea of having BEAMP in the first place. So I think these two will have to run concurrently. And if there are real concerns from the regulators, then the solution providers or the innovators will have to tackle that separately. But at the same time, I feel we should not be hindered by all these obstacles. We are supposed to overcome it with engineering sense. And I think that's my point of view of this question.
Thank you, Daryl. I think there's a follow-up question. Can you elaborate more about how does the expected outcome of 25% increase in casting cycle?
Sorry, can you repeat that question again?
Yeah, so the question is, can you elaborate more about how does the expected outcome of the 25% casting cycle? Do you have more context about that?
Well, if I have to be very frank, it is based on an estimate that I'm making. Let's put it this way. Normally in our precast plant, we will demold our components at 12 hours. But it's not the hours that actually dictates, but actually it's the strength. So we are looking probably at about 14 to 15 MPa before we are able to demold this. However, all this while we have always used 12 hours as the benchmark because that gives you a 1 hour, one cycle shift, right? So we believe that from a usual 12-hour cycle, first of all, even though we believe at 12 hours it can hit the strength, but sometimes we are testing it at more than 12 hours. Say, for example, we are testing it at 18 hours or 24 hours even. So with that one case example, you can see that there will be a significant reduction in terms of the number of hours that you take to test the cubes. The second part of it is that no one is for sure at this point in time whether we need really 12 hours. So when I say 25%, if you take 25% off that 12 hours, we are looking at 9 hours. That is a personal target that we believe we should be able to attain. That means in 9 hours, instead of 12 hours, I'll be able to cure the components to hit the minimum demolding strength. So that's, I guess, some of the basis that I based on. And to put 25% as a benchmark, I think it is not overly ambitious. It's how should I put it? It's not something that we are trying to save, but however, it is something that we are trying to assess and to evaluate based on our current testing method, whether is there something that can be done better using a real-time monitoring system. I think it's coming from that angle. Yeah.
All right. The last question for you. What specific parameters or properties needed to be tracked, and what is the accuracy or resolution required?
Okay, so parameters and properties to be tracked. I will leave this to the innovators. I think I earlier on mentioned that one parameters that we can correlate it to strength will be the maturity method, where you take the relevance between the heat temperature gain over a time, and then you will come up with a maturity index. Then from there, you ascertain the strength gain. That's one method. But if there are other solutions out there, I guess that's what this platform is for. And what is the accuracy resolution required? Ideally, it has to perform on par with our existing method, the cube crushing method. And if there is variance, I would say that that variance should be on the positive side. What I mean by that is that whatever solution that will come into the picture, it should, say for example, I'm testing the same cube at 12 hours. If I use the conventional method and it gives me 15 MPa, and if I cross-match it with the new solution at 12 hours as well, and it gives me, for example, 18 MPa, then it means that if I had tested it before 12 hours, I would have already attained the 15 MPa. So I guess that's the kind of accuracy that we are after, either that it is on par or it is actually performing better, because that's the whole idea of real-time monitoring. It's supposed to be more accurate. So that's how we came about to have that 25% time savings. I hope that addresses the question.
Thank you so much, Daryl. Thank you so much. I think that's all the questions for you. Guys, if you still have any questions, just drop them into the chat. We try to address them as much as possible. Next up, I would like to invite Suran from NetStill. He will be sharing more about the mechanical splicing of reinforcement bars.
All right, thank you. Good afternoon, everyone. So we have a assignment statement for you, which is how to mechanically splice rebars or reinforcements quickly on site with just visual confirmation using unskilled manpower and no tools. So let me explain in detail. So this is how the current splicing happens in Singapore. So it's through the mechanical joint, which is called as couplers. So couplers are basically like nuts and bolts. So you can see the threaded end, the bar with threaded end that goes together with the coupler. So couplers are basically hollow pipes with internal threading. So if I have to cut a section across the joint, it will look like on the, as you see on the left of the screen. The bar has the thread, which is this component, the threaded bar end, and the coupler, which is just holding it. So similarly, the other end of the bar is held in this coupler. So basically, the length of this thread is about half of this coupler. So this bar goes into the coupler almost halfway, and the other piece of bar goes into the coupler halfway. That's how it makes a joint over there. So this is a current mechanical splicing system, which is commonly called as couplers. So how we make this, we make the threaded end of rebar in the factory. And the coupler, which is the internally threaded pipe, this is normally a CNC made component, usually imported. So how do we make this bar end thread is by cold forging method. So we cut a piece of bar and then we cold forge it to enlarge the ends of the section. So once that is done, and then we go and do thread cutting over it. So after thread cutting, the diameter of the thread should not be lower than the original diameter of the bar. That's the idea we cold forge it. All right, otherwise the failure plane will be easily on the threaded part. So we try to forge it and then we do the thread cutting. All right, so what are the challenges we face currently? The first one is that when we do the cold forging, this shape, we like to get it, but normally we don't get it consistently. And because of that, the thread number of threads and the quality of threads are affected. So each batch, there are some variations. And these threads are very fine threads. The pitches generally vary from 2.5 mm to up to 5 mm. So smaller sizes of rebar will have 2.5 mm pitch, and the larger rebar sizes will have about 5 mm pitch. So these are fine threads. So when you try to make a joint on site under very hot and humid conditions and under without shelter over your head and with heavy pieces of rebar, it's very difficult to align the fine thread with the coupler. So that gives a challenge of cross-threading. So you may not fully engage all the threads into the coupler. It may cross-thread and then refuse to go in further. Then we have to bring in a wrench to tighten it. And even after doing that, there could be 1 or 2 threads which still refuse to go inside. So that will throw questions on the quality of the joint. So normally there's RE and RTOs on site to check visibly whether all the threads are being fully engaged by the coupler. If not, then it's considered as a non-performing joint. Then we need to remove it and then have to reinstall it. But once you do that, you have already damaged the coupler. This left-hand side of the coupler is already casted into concrete. There's no way you can remove it and then replace it. So you have all those challenges. And also you need manpower. For example, the piece that you're trying to join to the coupler, if that rebar piece is 4 meter, 5 meter long, some cases it happens. And it's quite heavy. You need 3 or 4 men to hold the bar in straight alignment with the coupler, and then you have to turn it. So it's a very challenging one. So this actually throws opportunity to create something that is much more easier to use and is faster, quickly done with less manpower. So we are open to alternate designs of couplers which can satisfy our requirement. I mean, especially those key requirements and key challenges that I listed below. And we also open to other innovative way of mechanically joining 2 pieces of rebar. Forget alone couplers. You can have other methods of joining 2 pieces of rebar mechanically. So it's like thinking out of the box. So what are the key requisites or key performance requirements? One of them, and the prime most important, is that the ISO, ISO 15835 standard. So this standard details what are the performance requirements of these couplers. So some of the key requirements, performance requirements are tensile strength, meaning that when you do a tensile test on the joint, coupler joint, the bar is expected to fail, not the coupler. So the joint should be stronger than the original rebar itself. And of course, we have these ductility classes in Singapore. So that certain amount of ductility behavior is expected from the coupler. Not to be very hard or very soft, but there's some ductility is expected. And the most stringent one is the last one, which is the slip, meaning that the joint after it's made, it should not slip beyond certain values. And these are generally very stringent in the order of less than 10 microns. So that's a very stringent recommend on coupler. All right, then we're also looking for no rotation coupler, meaning that there should not be a necessity to engage the coupler and then turn it, rotate it to fully engage it. So we are trying to look for a solution which do not require this turning or rotating of rebar process. And the proposed solution should cover bar sizes from 16 mm, the smallest, and the biggest is 50 mm diameter. So that's the usual range of couplers used in Singapore. And we are looking for a quick solution, meaning that normally when we thread the end of rebar, it needs certain operation, co-fuging, thread cutting, and then checking for quality. So all this takes about 10 minutes per piece. So we are trying to eliminate this part. And we are looking for on-site installation to be happening in about 10 seconds rather than 10 minutes currently, roughly around there. So in 10 seconds, you should be able to make a mechanical splice between two rebars compared to the current 20 minutes. So 20 minutes versus 10 seconds. All right. Then also the skill level needed for on-site installation should be lower as possible, because normally, as you know, there are traditional workers, foreign workers who are not that skilled, and they like to have something simpler and easier to use. And visual confirmation, that means the joint has properly happened, rather than having tools to go and measure whether it is properly engaged or not. So we are ideally looking for, but not limited to, push and lock system. That means you push two pieces of rebar into the coupler and gets locked up, or you press two pieces of rebar and it gets mechanically spliced. So this is not limited to do these two systems. It's open, but this we are throwing some ideas here. Right. So then, expected outcome, yes, we need an innovative out-of-the-box solution, if possible, and must conform to the ISO 15835 on the performance requirement. And the installation time overall should be about 10 seconds compared to the current 20 minutes. So we could support those prospective innovators on the technical aspects of couplers, especially on the ISO. And also we have an in-house QA lab, which has the tensile test capacity, especially the UTM. So we can provide those machines. So if you do not have it, then you can use our lab to test your prototypes. So that brings to the end of my short presentation. I'll open up for questions now.
Okay, thank you, Saran. Yeah, maybe a question for myself. Just curious, have you guys, what are your past attempts looking for solutions, and if there are any, can you share about some of the learnings?
Yeah, this actually we are trying to find a solution for almost 3 years, and we have come across certain designs which is used elsewhere, overseas especially. And we found that most of them or all of them do not conform fully to the ISO, especially on the slip requirement. Tensile, yes, they may pass. AGT, of course, no issue. But when it comes to slip performance, that's where all of them failed. Of course, they can achieve a joint in about 10 or 20 seconds. It's possible. But performance, when it comes to performance, they do not perform. So that's why we thought about why not we design our own couplers. As we know, as you might know that we are supplying couplers to Singapore market for over 50 years. And we supply almost 1 million couplers a year. It's not a small quantity. So it's worthwhile looking deeper to look for, what do you call it, out-of-the-box solutions.
I see. Yeah, and so what is your cost consideration? Is there any leeway? How much more expensive can the solution be compared to the traditional coupler? Actually,
we are saving something if assuming we achieve the set expectations of this coupler performance, assuming we have no threading to make and your joint can be made in less than 10 seconds, we're actually saving costs here, manpower costs, production costs. So all these cost savings could be utilized for the increase in coupler design or manufacturing cost, a new system. So we could have a balance, but end of the day, how the contractor, who is the user, or the engineer, the consulting engineers, civil and structural, how they view it is that what is the alternative for coupler joint, which is a normal traditional lapping of rebar. So you place two pieces of rebar side by side, and then you achieve the joint. So that lap length is about 1.5 meter to 2 meter. So every meter of rebar weighs certain kilogram. So you weigh what is the lap weight times the rebar cost. Say assuming it's $30. That 2 meter piece of rebar costs you $30. The coupler, they expect it to be less than $30 or slightly around $30, not more than that. If it's more than $30, then as you know, in our context of construction, they always look for cheaper alternatives. So then they will stick with the rebar lapping. So ideally, whatever the cost that we save with this new system, the process cost savings, could be utilized in the coupler product increase in cost if there is, and ideally keep it to less than or equal to lap cost. So the guideline will be a lapping cost.
Thanks for your sharing, Suran. Yeah, I think that's all the questions we have. So let me now invite our next speaker. Our next speaker is covering 2 challenge statements. So can I invite Soitin? The first challenge statement will be referencing and marking for fabrication of prefabricated bathroom units.
Okay.
Soitin?
Yes.
Over to you.
Okay. Thank you. Let me share my screen. Okay. So can you see on my screen?
Yeah.
Okay. Good afternoon to all of you. My name is Soitin. I'm the operation manager in Greyform. So I have this content 5 item for today. For the first item, which is actually the auto line mapping. So Greyform is actually a member of Switch Construction, and we actually incorporate in December 2015. We are actually in the ICPH, same as what Daryl Soybuild. So in Greyform, actually we have 2 business units. One is actually a PBU, prefabricated bathroom unit. And the other one is actually a precast production. So the first items that we are talking about is actually for PBU, prefabricated bathroom units. So Greyform PBU solutions is actually a lightweight concrete, which is actually related to our bath system in Italy, which have 20 years of production operation, right? So in Greyform, actually, we produce the lightweight concrete in 2 different types. One is actually a lightweight concrete. The other one is where we name it as a super lightweight, which is using a steel frame. Okay. Now, a PBU, which we do over here, is actually we assemble all the items in the factory before we deliver to the site to do the installation. So all those fit out, which is actually the WC, tiles, marble, shower screen or cabinet, including all the sanitary ware, will be installed in the factory before it delivered to the site, construction site, to do the installation. All right. So when we do the fabrications of this PBU, right? So there are many stages and many subcon or trade will comes into Greyform to do the installation of their items to our PBU carcass, right? So the first stage normally is actually from the empty carcass itself, we will install the conceal pipe or the system and etc. And when they do all these things, they will do a reference point and they do all the marking of where all the bolts and nuts they're supposed to be. all right? Then once they put up, then we have to do the waterproofing to cover up all these things. So the second stage of do the marking is actually just before the tiling, where they will do the marking of how the tile is supposed to be, the layout. Okay. And the third stage is actually after they put up all the tiles on marble, where are all the cabinets, carpentry that need to do the installation, as well as all the sanitary ware or the towel rail holder to be fixed up, or the toilet paper holder need to fix up. Shower rail. So in actual facts, all this is actually, we put it as 3 processes, right? So first is actually after carcass productions, where our plumber will go in to do the line marking for their systems or the consumed item. The second stage is actually after waterproofing, where our tiling or marble to put up all the lines. And then the third stage is after tiling, okay, where we put in the carpentry works, paper holders, and towel holders. So each of these trade of people will come in with their own reference line, and they will do their own marking according to their drawings that are required. So when we have all these things itself, then a lot of times where we have is actually each trade itself, if they don't communicate with each other properly, sometimes they will have a difference in the reference point, as such that some of the item might be installed in the wrongly. So therefore, our idea is actually to have a kind of robot system or any kind of things that comes in to do all this marking, centralized marking based on our BEAMP model data to do all these things. And of course, when you do this thing itself, it has to be easy to use this equipment itself, because the labels itself is actually a foreign workers. So it will be more likely a low-skilled workers to operate this machine. Now, to do all this line accuracy itself, so with the centralized of making all this line marking, so all this accuracy has to be at a plus minus of 3 mm. And when it comes to the tile, to do the tile line, some of the tile thickness itself is actually 5 mm with the adhesive of 5 mm. So it has to be less than 10 mm to do the reference line. Then, of course, the line itself has to be less than 2 mm, and it's actually visible on the surface for the concrete itself or the tiles. Okay. We have done a study of this thing with all the trades that comes in to do all this thing. It took about 150 to 180 minutes to do this thing, and sometimes you require 2 persons to do all this marking, right? So as such that with this systems that comes in, we hope it can actually reduce to less than 30 minutes, including the setup and measurement. Now, bear in mind also that we have to do the marking after the tiling or marble works for the carpentry or shower screen or the rest of the sanitary ware. So therefore, this ink that we use must be able to clean up easily and not leave any residues after that. So the solution itself should be a lightweight and easy accessible, right? So it has to be a compact size to it. Okay. So what will be our expected outcome for this whole thing itself? As I mentioned just now, it should be less than 30 minutes per bathroom units. And take note that it is actually not repeatable types, because every bathroom units have different types and different models, right? So it has to be high mix, low volume types. Okay. So that's all I have for this. Is there any questions for me for this?
Yes, so our attendees, if you do have any questions, do drop them in the Q&A section. I do have a few questions for Soy Tian. So can you share more about the typical size of your PBU, the prefabricated bathroom units?
Okay, so for one of the PBU size itself, probably around 1.8 by 2.4 in the length and breadth, with the height of about 2.4 meter.
Okay, yeah. And is there any speed consideration? How fast must the process be completed?
Typically, to do a fit up of the whole PBU's units probably will range from 14 days to 21 days. However, at each stage of this thing, like I mentioned just now, the total to do all this thing with just on the marking itself, it takes up about 150 minutes to 180 minutes. So we are looking at, by doing this thing, we can actually reduce to less than 30 minutes for each of these three processes. And then with this, we can have a centralized kind of marking to it. Yeah.
Sounds good. Sounds like a lot of time saved. All right. Soy Tian, let's go on to the next challenge statement. The next challenge statement is the automated inspection of precast components.
Okay. All right. So let me move on to the next one, which is actually the automated inspection of precast component. So the same thing, I will have 4 contents over here. Same waveform is actually the member of stage construction. So as mentioned just now, we have another division, which is actually a precast production. So our precast production is actually using the 2D dimensional components to do the productions, which we name as a pallet. And this metal pallet is actually going round, and that's where we name as a pallet circulation. So the components that we do it over here are basically columns, beam, wall, slab, and using the integrated system where data will transfer over to the production, right? So by doing so, actually at each stage of the casting itself, actually we do some kind of quality inspection, all right? Basically, we name as the pre-pour inspection and the post-pour inspection, right? So for the pre-pour inspection, where we check all the mold, the steel reinforcement, or the lifting hook, splice bar, connector, and any other things that we put in, right? To ensure that before we pour in the concrete. And then for the post-pour, it's actually to check all the shape, size, everything's correct. And all this is actually through the checklist that we have. So as you can see that each time on the picture itself, each time when we do all these things itself, we require the RTO, the RE from the client to come to our factory to do the inspections itself. So with the inspection, when we have the RTO or RE, then our QA/QC need to accompany him. Our supervisor or foreman need to accompany him to do all the inspections of this. And sometimes when we do the measurement itself, you'll need somebody to hold and to do all this thing, right? So, and to take photo, take pictures, to do as a records of all these things that has been done. So with such that we are actually keen to explore some kind of images or kind of AI that we can actually to do the analysis of all these precast component, where using the BEAMP model data. So first is actually using the BEAMP model data, and after scanning through our precast component, and it match against the BEAMP model data, right? With the precision of plus minus of 2 mm, right? To identify the total number of rebars that we have, top bar, bottoms bar, and any of these spice leaf or additional cast-in item to be considered. So with all these things that put in, then we can have one locations that put the camera and the pallets actually go around, straight away do the scanning and match with the BIM model data and produce the test reports for them. Any of the items that is actually out of the dimension, it will prompt up an error so that our people can actually do the rectification and retest again for that. So what we expect is actually a kind of automated inspection system using a image or laser technology for this thing. And then with all this, that we can actually came up with a reports, and these reports where we can send to the RTO or RE, which actually our RTO and RE need not spend all the way of their time from the construction site to our factory to do the witness of this whole thing. Yeah, so that's all I have.
Thank you. So I can just check whether we have some questions. So there's a question from Ivan. So what model return times would you need for the Reva scanning? And do you have the cameras in place or data scientists or analysts ready? And or you just need the model?
We do not have anything right now, but what our concept is actually, since we have the BIM model data, and our workers actually based on this BIM model data to do all the assembly of the steel reinforcement and then put into the mold. So therefore, we hope to have this kind of equipments or AI that you can actually do and match the result to the BIM model that captured whatever that we've installed to the mold and then match with the BIM model data.
Okay, yeah, thanks. So maybe one question from myself, is there any potential restrictions or challenges for installing the sensors on the automated pallet circulation system?
Actually, we also do not know, but what happened is actually the whole, our pallet size itself is actually about 3 meter width or 4 meter width, and then with a length of 6 meter, right? So the camera, we are not sure how this whole thing is supposed to be. Perhaps the system integrator can also come to grade form and then to look at the whole thing before they can actually come up with some things to that.
I see. And seems like there is a checklist. So would it be acceptable if the solution can perform part of the inspection, but not every item on the checklist? Would that be okay?
Well, at the end of the day, if let's say the whole checklist itself is not able to fulfill all, then the RTO or RE still had to be on site, then it defeats the purpose of this whole thing, right?
I see. Okay, one more question from Ivan. So may we know the file format for the BIM? Because we need to do a lot of processing of the files to match them with the format coming from the cameras in order to apply the AI.
Yes, in actual fact, this BIM itself is actually a building the integrated models that we have. So if you require all these things, then of course we can actually share with you of this BIM model data, and then from there you can actually see how we can make use of it.
Okay, thank you. One more question for this challenge statement. For the precast inspection, understand that even for static LiDAR machine, normally have an error about 2 mm around there. Have you explored this issue before?
Is this questions to Daryl then?
Yeah, I think it might be to Daryl. Okay, give me a moment. So any more questions for Soitin's last last challenge statement. If not, we'll open up questions if we have some questions, because we do have some questions coming in after the presentation. And since we have all the CSO with us on the call, we'll also open up the questions for the other challenge statements. So Daryl, there's one more question if you can help us answer for the precast inspection on the static LiDAR machine.
I'm just wondering whether he has been to our plant before. It seems that he knows that we have some of a laser scanning system. So I'll openly share. For the QA/QC, we have tried before using a laser scanner. So what it does is that in most ICPH, I can't say for all, the machine actually receives a digital file format from the BEAMP model. In our case, it's called the uni file or Unitechnic file format, which runs through the machineries. Now, encoded in this uni file itself, it will have things like your rebar dimensions, your panel dimensions, and all the different recesses and the different cutouts. So when you link this to the laser machine, what it does is that the laser machine will actually project it out onto the pallet itself. And then what it does, or what it is that the QA/QC guy will have a look at it. And if there are any lines that falls out of place, you can tell that that means the reinforcements or the panel has not been placed accurately. However, this solution eventually was not used. I still have the laser system. Reason being because number one, when you use a shuttering robot to place your formwork, you are expecting a tolerance of high level. Secondly, when you produce your reinforcements within the plant itself using a mesh making machine, you will also expect that it actually produces with very high tolerance. When I say that, that means it's close to 0 mm tolerance. So we realized that, eventually, number one, the way we produce is already giving you great accuracy. Number two, you still require a QA/QC to go down there and then to check and using visual method to take a look at it. So I think as what Soiken mentioned, it will be good if you have an AI solution to then cross-relate to your BEAMP model. I think you have a lot of things that you can do with the BEAMP model itself. But the challenge is then to have, be it a LiDAR system or a 3D imaging scanning system, to be able to accurately identify the rebars. Because even the 10 mm and the 13 mm rebars, for us itself, maybe practitioners, you can tell the difference. But for the camera to be able to tell the difference when you have so many congested rebars, it's not easy. And also on top of that, you have additional bars as well. And these bars does not form your main mesh. These are things like your lifting hooks, your trimmer bars, your rebars for temporary support. So all said and done, it can be quite congested. Then how can the camera or any system that you implement be able to detect it and then cross-relate it to the BEAMP model? So one part is the integration. The second part is the identification of it. I think internally we have tried it with one company before. I can't mention who, but they themselves also have some difficulties trying to identify the rebars. It's not as simple. So that's what I can share from my experience.
Thank you so much, Daryl, for sharing your insights. I think it's becoming a panel discussion on how to solve this challenge statement. But I do want to highlight to the innovators that, there's different types of precast components. And for this particular challenge statement, right, we're looking at the simpler, I guess, less congested precast components. But I think the innovator clarified that actually they wanted Soiken for you to to also gather your insights in terms of using LiDAR to do the inspection.
Okay, so I'm not sure what is this LiDAR for this case here. I will only hear from Daryl just now on this thing. So if like what Daryl just now has mentioned, if at the end of the day the QA/QC still need to go down to the site to look at all these things and then to match all these things, then it become back to the square lah. You go back to the origin. Yeah. So the ideas of this thing is actually also looking at the those electronics firm where they do the lead frame inspection on the transistor lead frame or IC lead frame inspection, where they use a camera and match against the product, and then to tell us any errors from there. That's all, and able to come out with the reports to say that everything in good order and you can start the production. That's all I can say. Yeah.
Thanks, Soy Tian. Yeah.
So again, there's another question for you for the other challenge statement on the prefabricated bathroom units. So the question is, for the robotics part of the referencing marking, will the savings included in the manpower spent on operating the robot? Will there be any obstacles for the robot to climb into the PBU unit as it is normally elevated?
Our PBU itself is actually in the factory location. So there's no need to climb in and out for this case here. All right. And the 13 minutes itself is actually including the so-called setup itself. Right. So assuming that we are thinking that the operator can just push this cart or bring this equipment, put at the center of the PBU, and then it will auto do the calibration, do the measurement, and do the marking itself. Something of this. Yeah.
Thank you. Yeah. So do we have any more questions from the attendees?
Just now I saw a raised hand.
Yes, I saw that too.
Yeah.
I put it down.
We will allow you to talk. I believe that perhaps your question might be quite long. So yeah, we have given you access.
Yeah, hi. Okay, so KK here. So just now pertaining to the race platform, why I asked this was because since we have to some point justify the manpower savings or productivity savings on top of the solution, right? Given that current the workflow is 150 minutes per one or two manpower that is assigned there. The justification for that topic would be that if since now there's the machine, the PBU is actually elevated from ground, so technically there still have to be an operator there maneuvering the robot so that they can do the marking of the levels lah. So then wouldn't the proposal be a bit more hard to justify in terms of productivity or gains when that was your initial target?
I would not say that it's actually hard for that sense. If let's say this is just like a briefcase or the kind of things that comes in and then able to do all the marking itself, then it's the same as the workers to bring their tools with a trolley that moving on to that. So current, of course, is actually there will be different trade of people. There will be each and everyone will have their own reference point. So with this, actually, we will have a centralized everything by one machines to do all this marking for them, so that everybody are aligned with this line. That's number one. Number two itself is actually when we do all this line marking, sometimes you require 2 persons, because when you do the marking itself, you need 2 persons to one hold the other one to do the spring effects of this whole thing. So yes, with this, only 1 person will do.
Okay. So, yeah. So in that sense, I can still justify in terms of any productivity gains, even say with 1 person. Like it's not like compared yes, to no manpower.
Yeah, you still require 1 person to at least push this cart or this robot or whatever you come up with to do this part of the job. Yeah.
Okay. Then another question is on the last statement for the precast rebar checking,
inspection, yeah.
The whole process for inspection. So understand that based on certain hardware limitations of potential solutions, and you have mentioned about all 4 phases from pre-rebar installation until all the way to concrete casting, right? So if let's say the solution would only, if let's say there are some confidence in having a solution to detect one portion of the full flow, would that still constitute a good proposal? Kind of like, is it a must that we must complete all 4 phases, or if our proposal would be able to have enough confidence to do one portion of it?
Probably that will actually only come to the stage 1 of what you the initial portion, because at the end of the day for us it's actually the whole thing itself, where you just need to have one QA/QC operator to operate the whole thing, and then the report just sent over to whoever needs it.
Okay.
Yeah.
Okay. No, but I don't mean like sending of the information. I was referring to like due to, for whatever reason, in terms of practical limitations, that like what Daryl has mentioned on the 10 mm versus 13 mm accuracy, and that might sometimes lead to unnecessary false negative, or I mean false error lah. And that would normally comes in place in terms of the practicality of all 4 phases to be automated.
Yeah, of course, if let's say it's actually stage by stage, and then ultimately the end solution itself is actually able to comply with all the needs, that's where there's our ultimate goal. Because at the end of the day, if we were to buy this equipment, only solve a portion of it, and we still require the same group of people hanging around to do all the inspection, then it defeats the purpose, right?
Yeah, okay, I'll see how we can adjust. Yeah, thanks.
Okay.
Yeah, so there is a follow-up question based on this sharing. So I think you mentioned about the 30 minutes, but how much man-hour savings should they be aiming for with the digitalized solutions versus the manual process, the current manual process? So is there additional man-hour savings that you're looking for?
Like I mentioned just now, the current practice itself is actually they take up 130 minutes to do all this thing, or to 150 to 180 minutes to do all this thing. And that's where, if we are able to have such kind of systems that able to reduce everything to 30 minutes, and that actually comprise with the peoples as well, because the 150 to 180 minutes is actually including 2 person, sometimes 2 person to do it, and some trade itself is actually 1 person. It's actually included in. Yeah.
Thank you, thank you. All right, since like we have covered all the questions, I will just open up for 1 more minute, just in case anyone wants to type. If you don't want to type, you can also raise your hand, then we will grant you rights to speak. All right, okay, Ken, so that's all for our session today. Please go ahead to apply now on BEAMP.sg. And just a reminder, those who have an early submission before 14 October do stand a chance for early review, as well as a consultation with our CSO, just to understand each other better and revise your proposal before the actual deadline. So if you have any questions after this call, you can also drop us an email at bm@padang.co. So my colleague will be dropping the email down, bm@padang.co. So if you have any inquiries, you can also reach out to us after this session. All right, thanks everyone for joining us in this call. We'll take care. We'll see you soon, the next Q&A session. Bye-bye.